Hi, everybody. My name is Jason Frazer. I'm a meteorologist with the NBC affiliate in Cleveland, Ohio, WKYC or 3 News. I want to thank each and every one of you for tuning in to this video. This is our second video, and today we're going to be talking a little bit about temperature as well as wind. So, as always, when I get started with these lessons, I like to start off with something a little funny. I like to call it my joke of the day. All right, so you ready? Here goes. What kind of shorts do clouds wear? Five, four, three, two, one. All right, here's the answer. What kind of shorts do clouds wear? Thunderwear. All right. I hear each and every one of you laughing at my joke. Thank you very much for entertaining. All right, so I love all of your questions. If you can feel free to leave me a question right there in the comment section, or you can also feel free to email me at jfrazer@wkyc.com. That is jfrazer@wkyc.com, and I will try my best to get back to you as soon as I can. Just remember, there's a lot of you and only one of me, so it may take me just a little bit of time for me to respond. But I love all of your questions, and I promise you, I will respond to your. All right, so here's today's outline for today. So we're going to learn a little bit about temperature. What is temperature, and how does temperature impact the weather? And what causes the wind? All of us have experienced feeling wind and even seeing the effects of wind, but what exactly is wind and what causes it? Then we're going to talk a little bit about how wind impacts lake effect snow, how it actually creates lake effect snow, and then the final topic for today is going to be talking about weather watches as well as weather warnings. Are you ready? All right, let's go. All right, so my first question for you is, what is temperature? I know that a lot of times people know when it's hot or whether it's cold. As a matter of fact, when it's cold, what do we normally do? We normally just put on the jacket and, yeah, we try to get warmed up again, right? But what exactly is temperature? Now, I had to go to dictionary.com in order to find. They evaluate temperature as, quote, a measure of the warmth or coldness of an object or substance with reference to some standard value. Whew. Well, thanks, dictionary.com. Now I'm even more confused about what temperature is. Well, in its plain English, basically what it means is it is the way that we define whether or not something is really warm or really cold, and we have an independent way of verifying that. And we do that a couple of different ways. Alrighty, so we have a couple of different ways that we can independently tell what the temperature is going to be. It's very similar to how you have 3 different ways that you can evaluate your favorite slice of cake. Maybe you evaluate it based on the color. Maybe you evaluate it based on the taste. Or maybe you just evaluate it based on how big it is. And by the way, if you want to buy me a slice of cake, I'm a big fan of carrot cake, and you can send it to 13. I'm sorry. We should be talking about weather. I'm sorry. All right. So there's 3 different ways that we can measure temperature. We can measure it based on the Fahrenheit scale, the Celsius scale, or the Kelvin scale. Now, you're probably more familiar with the Fahrenheit scale because that's what we tend to use in a lot of places across our country. All right, so first let's talk about Fahrenheit. So when you're sick and you don't want to go to school, you probably will tell your parents, "Oh, I have a cold, I don't feel well." One of the first things that they'll likely pull out is a thermometer that looks just like this. And they'll try to take your temperature. And your temperature is actually usually in Fahrenheit. See, just right there. All right. Now, normally what will happen is I should be a little bit warmer than 93.6 degrees. Should be about 98 degrees. But what happens is Fahrenheit is a independent way of evaluating whether or not something is warm or whether or not it is cold. Now, it was created by this man that you see there on the screen, Daniel Fahrenheit. And as you can see, he was a sharp dresser. He didn't like to smile very much, but man, did he care about his hair. I don't see one piece of hair follicle just out of place. My man, you are looking good. Now, Fahrenheit was a German physicist, And he defined his way of evaluating temperature as 32 degrees being the freezing point. Now, 212 degrees, well, that was the boiling point. Now, Fahrenheit is still the primary way that we evaluate temperature here in the United States and some other US territories. But as we go to other countries, one of the things that you're going to find is that they use another system. That system is called Celsius, and that was named after a Swedish astronomer named Anders Celsius. Now, Anders Celsius had basically said that the freezing mark should be near 0 degrees. The boiling point should be somewhere around 100 degrees. And like I mentioned, this is largely used outside of the United States. So places like Europe, Asia, Australia, even most parts of Africa, they usually will define their temperature using Celsius. Now, there is a very interesting, complicated formula for how to take a temperature in Fahrenheit and put it into Celsius and vice versa. But that's a little bit above where this class should be. But in another future class, I'll probably teach. Now, one of the other things that you may have heard is something called Kelvin. Now, this was named after a man called Lord Kelvin. And as you can see right there, he was also a scientist that didn't really like to smile. Now, usually Kelvins are usually used by scientists. They're not really commonly used by other people. Now, Kelvin basically is the idea that everything that vibrates has some sort of heat. And when that very thing no longer has heat, it comes to a complete standstill. So when you're using the Kelvin way of evaluating temperature, it's the thought process that something that is absolutely so cold it doesn't produce any sort of heat. That is zero. It is cold. You can't get any colder than that. The boiling point with Kelvin is actually 373.15 degrees. Whew, that's hot. Now, one of the things that we had discussed during our last lesson was usually the further you go up in the sky, usually the colder it gets. And I'm going to use this sand thing here to describe this just in case you forgot this. So usually all the way at the tippy top of the sky, usually when you're flying at 35 or 40,000 feet in the air with an airplane, it's usually like really cold. It's like negative 40 or 45 degrees. It is cold out there. But as you get closer and closer to the ground, it usually gets a little bit warmer, and then even more warmer. Now, what happens is sometimes you'll actually get some warmth right here, even though it'll actually be colder down here than it is up here. We call that a temperature inversion. And sometimes that'll actually happen in weather, and there's really cool different things that'll happen. So you might remember this precipitation type that I described the last time. Remember I had talked about freezing rain as well as sleet. And what happens is most moisture in the upper atmosphere starts out as what? Snow. And I had brought out some ice and I had burned some ice. It was actually a lot of fun. But most precipitation in North America starts out as snow. And as it goes further down to the ground, what type of air it encounters will depend what you actually see on the ground. So if it encounters very warm air, well, as you can see, it's going to hit the ground as water, or as we commonly refer to it, as rain. So that means there was no temperature inversion, right? Because, well, it encountered much warmer air as it went further down. But when you start to see freezing rain or even sleet, that basically means that at some point the air was really cold up here, but it encountered some warmer air like somewhere around here. So we're talking potentially above the freezing mark. So anywhere between 32, maybe 33 degrees Fahrenheit. But then as it got closer to where you are on the ground, it started getting cold again. So temperature inversions are something that a lot of meteorologists look for, particularly when we're trying to figure out what's going to happen in your neighborhood. Is it going to be freezing rain that's going to happen in your area? Or might we see some sleet? Or maybe we see some snow. That's why we're always concerned about what's happening not only at the ground, but also what's happening really high up in the sky. So Fahrenheit, Celsius, and Kelvin are independent ways that we can evaluate when something will boil, when something will freeze, and when you might need a jacket versus when you might just need to wear a polo. Now, sometimes on the news, you'll hear me talk about this thing called real field temperature or wind chill. It is basically the temperature that it feels like, even though the air temperature is very different. And I know that may seem a little confusing. So here I go with another glass of water to try and describe another meteorology term. So if I have a glass of water and the water is about 32 degrees, but I blow over it, is it going to necessarily change the temperature? No. But if I'm standing on the opposite side and I'm blowing on this, you're likely going to feel a little bit cooler, even though the air temperature hasn't changed. Now, the problem with this concept is depending on where you are in the world, we define this a little bit differently. So there's no massive agreed upon way of defining wind chill or the real field temperature. So here in the use this chart to figure out the real field temperature or the wind chill. Now, this is a chart that was created by the National Weather Service, and there's a couple of things that are going on here. First things first, let me tell you about frostbite. Now, you may see frostbite times down here. What that means is you could get injured just by standing outside for too long. That's the reason why your parents often tell you to wear your gloves, wear your hat, wear your jacket during very cold weather. All of the numbers that you see here represent what the temperatures feel like against your skin after a certain amount of time. Now, if the temperature feels like this for about 30 minutes, you're at risk of getting frostbite. Now, if you go all the way to the right and you see these temperatures right over here that are in purple, well, that means that you can get frostbite within 5 minutes. Now, at the top of the chart, you'll notice here that these are temperatures in Fahrenheit, right? And they go down the chart by about 5 degrees. And on this side of the chart that you see right there, those are wind speeds. Now, all of the winds in the United States are measured in miles per hour. When you get to other countries like Canada, for example, they actually measure the winds in kilometers per hour. Now, because we have this wonderful chart, we can evaluate what the temperature is going to feel like against your skin. So if I have a temperature that's 30 degrees and I have a wind that's also 30 degrees, what is it going to feel like against my skin? Well, we just go down the chart here, and then we see against my skin, it's going to feel as though it's 15 degrees. Now, because I'm in that light blue at 15 degrees with a 30-mile-per-hour wind, that means within 30 minutes, I could start seeing signs of some frostbite. So during very cold weather, you don't want to be standing outside for very long. All right, so that brings up another question that I often get, which is what exactly is wind? Well, wind is just basically air moving from one place to another. And in the atmosphere, which is the thing that we often see as we walk outside, it occurs as a result of a difference in air pressure. Now, usually you will always have air that likes to move from high pressure to low pressure. And pressure is one of those things that is very, 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 very important in meteorology. And in future lessons, I'll tell you a little bit more about high pressure versus low pressure. But if you remember, high pressure, that makes us feel happy. That generally means we're going to have a clear day. Whereas low pressure, that usually means a storm is coming. And that usually also means we're going to see some clouds as well as some rain. Now, we measure wind a couple of different ways. Now, these are some of the weather instruments that I use. Does anybody remember what an anemometer is? All right, so if you answered it measures wind speed, you're correct. Well, and the wind vane, yep, that actually measures wind direction. So those are two very important things that I utilize every single day for wind. Now, here are some very cool facts about the wind. We always refer to the wind direction from which the wind is coming from. So I know that that can be a little bit confusing, but for example, if you have wind that's moving from the east to the west, we call that an easterly wind. So if the wind is moving from this direction to this direction, that would mean it's likely moving from the left portion of your screen to the right portion of your screen. So I guess we could call that like a lefty wind. I don't know. That would be really interesting to actually see in reality, right? Now, I know a number of you are really smart. So if you ever end up on Jeopardy, I want you to remember me because you might be asked a question. What is the fastest wind gust that you have ever experienced on Earth? Now, some of you might say 50 miles, some of you might say 75 miles, and you're right. That's how far the wind, or I should say, that's how much the wind has blown in your area. But the fastest wind gust ever recorded was actually from a storm that they call Tropical Cyclone Olivia. And it blew a wind gust of 254 miles per hour. Woo! That was really powerful. Could you imagine that? That's like that's like putting together, I don't know, a lot of balloons and just releasing them all at the same time, like over a million balloons, and you're just standing there and just psh. I know. It's kind of crazy, right? Well, it happened at the Barrow Islands, and that is off the coast of Australia. So a lot of times tropical cyclones are called hurricanes here in the United States, and they can be really powerful storms. So, what are some things that impact wind and wind speed? Depending on where you are, wind speed can actually be impacted by temperature differences. So, and this is something that happens a lot of times with turbulence. Some of you may have seen me in schools talk a little bit about turbulence, and I often think turbulence is really cool. So, I'm going to use my trusty thermometer here. And what happens is this: if this is your plane, and we are moving along, flying along, and your plane senses a huge temperature difference, sometimes what will actually happen is that those different air masses will actually fight for supremacy. And when I say supremacy, it means that they're fighting for control. And what will happen is you'll actually start getting wind as a result of that. Your plane will actually start shaking a little bit. A lot of people know that as turbulence, or as I like to say, it's when your plane arbitrarily likes to do the stanky leg in the middle of the air at 40,000 feet in the air. And let me tell you, if you're like me, I don't like turbulence. Why? I like to be in control. I like smooth things. Thing that also impacts wind speed is location. So if you're in a city with a lot of tall buildings, you tend not to see as much wind as those of you who are literally on the water. Why? Because it's this thing called friction. The wind doesn't have to hit anything to move. It just moves like it just wants to move. So if it wants to move left, it can move left. If it wants to move right, it can move right. Anytime you introduce buildings or other things around it, it basically acts as a way to block the wind. So let's say, for instance, this is my wind, and let's say this is a building. What happens when the wind hits it? It's got to hit it, and then it's going to start to go around. Now, sometimes what will happen in places like Chicago or even New York is sometimes it'll cause the wind to feel as though it's more powerful because it actually has to go around it. But usually, whenever you introduce what we call friction in the meteorology industry, that usually tends to slow down the speed of wind. One of the other things that impacts wind speed is other storms. So if you're in, let's say, Cleveland, Ohio, and it is a nice, bright, sunny day, but there's a storm that's approaching, what usually tends to happen before you see the storm come? Well, usually you'll start to feel the wind. Usually you'll start to see the trees start moving around. So other storms, depending on where they are, will impact how fast the wind goes. And that was pretty interesting stuff to see too. All right, and that brings up my next point about lake effect snow. So sometimes the wind can actually end up creating weather. So lake effect snow is one of those fascinating things where out of nowhere you can actually have a snowstorm. Or sometimes you can actually have this thing called lake effect rain showers as well. But most people in the Midwest along the Great Lakes and even in the Northeast are more familiar with lake effect snow. And here's what happens. According to the National Weather Service, this is their graphic. Usually you have to have warmer water. So water that's anywhere over the 32-degree mark. Why? Because at 32 degrees, water freezes. So usually it has to be warmer than 32 degrees, and you have to have a really cold wind. And what happens is that cold wind goes over that warm water, and then you start to see a little bit of condensation, start to see a little bit of that cloud cover. And then you'll notice there that eventually the clouds start forming right there. And then because we have a whole bunch of cold air that's moving in there, what happens? Remember, what did I say about precipitation types? What happens if there's cold air up here and then cold air down here? What type of precipitation do you usually get if it's above the freezing mark? Snow. And that's essentially what happens with lake effect snow. So, the best way to describe this, also again, I keep comparing everything to this glass filled with ice as well as water. A lot of times you'll start to notice some condensation that'll develop on the side of your glass. And I don't have enough ice in this example here, but a lot of people either drinking, maybe you've drank a can of soda, or maybe you started to see like that little cloud that develops on the side of the can or even your glass. That basically is exactly what's happening over a body of water like Lake Erie or Lake Michigan. And usually, what you'll need is either a northern wind or a westerly wind. And that is because what happens usually in the north or in the west, it's usually a bit colder. So when you get that cold air that's coming off of Canada, that usually will cause some lake effect snow showers during the winter months. All right, so the last thing we're going to talk about today is weather watches and warnings. Now, sometimes maybe your parents will get an alert on their cell phone and it'll say thunderstorm warning or thunderstorm watch. But what does that mean? So watches are nothing more than basically it's a warning that basically says, hey, something is going to happen, possibly in the next 30 minutes, possibly something in the next hour, 2 hours, 3 hours, maybe the next day. Whereas whenever you get a weather warning, that means it's likely going to happen or it's about to happen. So there are different types of watches and warnings. Sometimes you'll hear me or other meteorologists on TV talk about tornado watches versus a tornado warning. Tornado watch, again, means that it could happen, whereas a tornado warning basically means that, hey, we're seeing something on radar or we're seeing something on one of the cameras that we're looking at that indicates that there's a tornado on the ground. And if you've ever seen a tornado, let me tell you, it is really scary to see. And it does sound like a freight train. Some other watches and warnings we can get are severe thunderstorm watches or severe thunderstorm warnings. We can also get winter weather watches as well as winter weather warnings. That usually means we're going to get either some ice or some snow. Sometimes you'll also hear me talk on the news about a high wind warning. What does that mean? That means we could end up seeing winds that are 40, 50, 60 miles per hour. Now, it's important to note that we at the TV station or radio station, we don't decide on watches and warnings. We do not issue them. All watches and warnings, they all come from the National Weather Service. We are basically just the vehicle that they use to let you know about what's happening. Now, the cool part now is if you have a cell phone, your cell phone provider can also automatically get in touch with you with those watches and warnings. All right, so that's it. You made it through yet another lesson of Jason's Weather School. Hopefully, you have learned something today. Now, tomorrow, March 31st, we're going to be talking about fronts. Sometimes on the news, you'll hear me talk about cold fronts versus warm fronts versus occluded fronts. So, what is a front and why do fronts form? We're going to also be talking about how fronts can lead to storms being created. So, why does a random snow shower happen as a result of a cold front? I'm going to answer that question tomorrow. And we're also going to talk about different types of thunderstorms as well. I hope that you have learned something. Maybe there's something that I covered during this lesson where you have a question, or maybe you're a little confused by a concept. I'd love to answer your question. You can feel free to contact me on Instagram, Facebook, Twitter, as well as Snapchat at Jason Frazer TV, or you can leave a comment right there below this video, or you can feel free to drop me an email at Jason, or I should say at JFRAZER at WKYC.com. That is J Frazer at WKYC.com. I hope to see you tomorrow, where we're going to be talking about how and why these storms develop. Bye.